So welcome to our talk on observable microservices. I'm Taruj Mathur. I'm a lead consultant and a client tech principal at ThoughtWorks.
And I'm Maria Gomez. I'm also a lead consultant and a market tech principal at ThoughtWorks in Spain. And we are going to talk today about microservices, but only focus on observability, which we are going to define in a moment, but it's all about how we maintain and operate this type of architectures. So in this talk is kind of based, or has been inspired by the experience that both of us have had in different clients, in different domains in the last 3 to 4 years at ThoughtWorks. So we've been really privileged to be able to help different companies and different people and teams to, be in implement this type of architectures, even assess if that architecture is the right choice for them and their situation. We have seen a lot of successes, and we have also seen a lot of failures. So we are gonna give and share with you some of the challenges that we face and some of the things that work for us.
So before we get started, can I have a show of hands? How many of you are maintaining microservice-based systems in production right now? Okay, so there's quite a lot of you. How many of you are building microservices or planning to build microservices over the next few months? So if you're already maintaining microservice-based systems in production, I'm hoping you would have run into some of the same problems that we've seen. And hopefully you've come to some of the same solutions. But either way, if you have new insights to provide us, we would love to talk to you after our talk. So let's get started. Building microservices. I hope a bunch of you have heard of or maybe read this book. Sam Newman wrote this book a couple of years ago. And it basically pulls together our learnings and experiences with talking to companies that have been building microservices for a while all around the world. And in this book, Sam identified 7 important properties that a microservice should have. So a lot of the properties at the top of the list talk about how you would go about building and designing a microservice. Whereas if you look at the 3 at the bottom, they're essentially around how you go around deploying the service and maintaining it in production. So highly observable is a very important property of a microservice if you are trying to maintain a system built on a mesh of microservices in production. So before we go further, let's define what highly observable microservice means to us. So in this context, we define observability as a way to interrogate your system to get accurate answers that improve your understanding of this system. So there are a few things to unpack here, right? One is we want to interrogate our system. So the services that we are building, the system that is composed of these microservices, we want to be able to ask them questions and have them give us answers. And these questions don't need to be technical ones, right? So I don't need to just ask you, hey, how many threads are you running, or what's your response time? These questions might be business-based. So I might want to say, hey, how many users are adding items to the shopping carts, or how many users are moving to payment after putting things in the shopping cart? So they could be business-based, they could be operation-based, they could be purely technical. But I should be able to ask my services, my system, these questions and get an answer. The second thing is that this answer needs to be accurate, right? Because if you're trying to debug production issues, or if you're trying to make business decisions based on data that you're seeing in production, you want this data to be as accurate, as up-to-date as possible. You don't want to make these decisions or figure things out based on out-of-date information. And the third thing is that these answers should improve your understanding of the system. So this basically speaks to the fact that if I ask a service or a system, hey, tell me about yourself, it can provide you reams and reams and GBs of data, right? The number of threads, the amount of memory, CPU cores, number of users using me, API response time, a lot of information, right? But it's very easy for you to get buried under this noise and not be able to actually find the answer to the question you're trying to understand. So it's important that my system gives me pertinent information and not just all the information in the world. So in practice, when we think about implementing observability in a service, we come to usually these 4 or 5 pieces. It's essentially logging, monitoring, visualization and alerting, and finally tracing. Now each of these has a lot of nuances when you're talking about microservices, and you can probably do an hour-long talk on each of them, which we are not going to do today. But hopefully, we're going to cover some of the important things we've seen that have helped us make useful systems that work in prod. So let's start with logging, right? So logging, I think every dev in the room would have done logging in their life many times. It's actually one of the most common and the simplest way that we have for systems to tell us about themselves, right? And logging in a non-microservice world used to be far more simpler, right? Because you had a smaller set of systems to deal with. You would generally do a naive logging implementation, log things onto a file on the server. You could SSH into that server, read the logs. Life was good and simple. But once you start thinking about microservices, you now suddenly have a lot more systems. You could have tens or hundreds of systems, right? So this whole mechanism of SSHing into a server and figuring things out no longer scales, right? It's not a viable strategy for us. So one of the most common patterns you run into as soon as you start building a microservice-based system is log aggregation. So basically, you want a way to collect all the logs across all your systems, all your services, all your servers, get them into one common data store that allows you to query it very easily from one place, and then exposes it to your monitoring and visualization systems. Right? So this, again, basically means that if I want to ask questions about my system, I can go to one place. I don't have to go server by server and try to figure things out. Now, the good thing is it's a very common pattern nowadays. So there are a lot of tools available for you to get there. You have the Elk stack, which is pretty popular, Elasticsearch, Logstash, Kibana, where Logstash allows you to pull in logs from different servers, dump them in Elasticsearch, which is a searchable index for you to use, and then Kibana allows you to visualize things and ask questions and get the answers you want. If you actually don't want to go the build-it-yourself route, you can also have commercial offerings like Splunk, which pretty much offer you a similar thing in an easier, simpler package. I have microservices, we're logging a bunch of things, I have log aggregation in place, I can ask questions, I can get answers. Are we done? Well, something you'll find very soon in a system of microservices is that it becomes really important for you to figure out what to log, right? Because when you have hundreds of systems working together, there's a lot of log information being generated by them, right? And just because they're all available to you in one server doesn't really mean that you can query them meaningfully or make sense out of them. So one thing we recommend everyone to do is move to a structured log format. So if you have 10 teams building 10 microservices, you don't really want them to go around logging things in a format they all made up, right? Because even though I have all my logging information in one place, I can't query it because every information, every log has a different structure. So one of the common formats we've seen is just to use JSON with key value pairs. These keys basically provide you dimensions that you can search against. So for example, if I track component ID as a key, I can say, hey, find me all the errors that occurred for this component in the last hour. So I can run queries like this because I have a structured log format that my tooling can parse and make sense of. Another thing to remember, and I touched upon this before, is that when we're talking about logging, most people just think in terms of errors, whereas we want our system to be able to answer business questions as well, not just exception cases. So it's also important for you when you're building out a feature, when you're working on a story, to think about what are the business events that come out of this that I would care about, that I would want to think about, and then make sure that the structured logs that you spit out actually take care of these. Another thing that you learn pretty fast when you have an organization building microservices is that you want to standardize as much as you can, right? So this doesn't mean that all your log messages will be exactly the same. Every team building their microservice might want to log things that are very specific to them in their own specific structure. At the same time, because we want to fire queries and we want to run these queries across a system of microservices, you would want to standardize on at least a few key important dimensions that every microservice is logging. So you can actually start asking deeper questions that go across multiple services instead of just focusing on one service at a time. Another thing that's very helpful is for you to build logging into your service template. So this means that whenever a new team starts a new service in my organization, the common logging standards, the common logging structure is already baked in. Right? They spin up a service, the service is already out of the box, logging data in the format that we want them to. And finally, you want to make sure that your log aggregation infrastructure is common across your organization. You don't want 10 teams with 10 microservices dumping things in Kibana, whereas you have 5 teams here dumping things in Splunk, because that means that if you want to ask any useful questions from your system, you again have to ask a question here, merge those answers. So there's a lot of manual work you're doing. So you want to make sure that the effort that you're investing into this actually pays off. So standardizing your log infrastructure becomes very, very important.
Cool. Okay, so the next topic is monitoring. Monitoring, to me, has one specific goal, and that goal is that it provides me with enough information to make decisions. So, it can give me information and metrics about how my systems and my services are performing, so then I can see if I need to change things. And it can also provide the business with metrics that allows them to validate assumptions or validate hypotheses or bets that they have made in certain products. Monitoring, the way you approach monitoring is by tracking certain data points. So you choose what are the data points that are of interest to you, and you just track them, right? And one very specific thing is that that logging aggregator will put some of that tracking or some of that information in that data store, and your monitoring tool can query that data store to get those metrics. But you can get metrics for a bunch of other places, like Google Analytics is a really good example of that, of how you can introduce some trackers in your pages to retrieve information about how users use your website. It's very important that we understand that monitoring is not a thing that you do at the beginning or at the end and then you forget about it. It's a thing that needs to be evolving in the same way that you evolve your architecture and you evolve your products and your services. So the easiest way that we have found to do that is that you will bake all of these monitoring requirements into your user stories. So then when you implement a user story and a functionality end-to-end, you're also thinking about what are the data that I want to monitor to validate that this functionality works as expected. So I'm going to give you a little example of something that we are doing in the current projects that I'm working on. My project, or the project that I'm working on, is for an online marketplace. They work across Europe, so they are quite big in Europe. They have, like, how many I take here? Like more than 3 million articles. So they have a lot of visitors, and it's a really high performance system. So in my team, one of the functionalities that we had to implement required us to create a new microservice, right? So that new microservice is very simple. When we started, the first user stories were about creating a microservice that was reading from a data stream. It was transforming that data and then putting the result into another data stream, right? So we also thought about what are the, in this case, operational metrics that we wanted to monitor, right? So for us, a very important operational metric was to say, hey, is the service actually working, and how can we monitor the health of that service? So we started for that, right? Creating a health check endpoint, which is a very standard way right now nowadays to assess the health or the status of a service, right? So You have an endpoint, and that endpoint just responds true or false, depending on whether your service is healthy, is running or not. So the first thing that we do is just we just put that in. If you can actually query that endpoint, then it will always return you true. And if it returns something else, then that means that the service is not running. Right, but then, we also have 2 data streams. So those data streams can be, our service can be up and running, but maybe can't connect to any of those data streams. So we need to also add that as an interesting piece of information that we want to track. So we also add into our health check endpoint the validation that we can actually connect to the 2 data streams. And that was it, right? That was our functionality was built. We put it in production. It was working fine. We monitor the state and the status of our services that way. But then we had a new requirement that came, a few weeks later, and that requirement was about, serving that information to other consumers. So we had to serve the information that we transform to our mobile app and a web app. So that means that we also expose that information through a REST API, and we have a database that was storing that projection that there was to be served as a JSON response. So that means now that we have other pieces and other dependent systems that we also need to track, because our service can still be, our health check can still be returning as true if the service is up and running, it connects to the 2 data streams, but maybe the database is down and we don't know. So we also add that information in there. So you see, that's an example of how your monitoring and the things that you track will evolve with your development. And the easiest way that you have to make sure that you are keeping yourself up to date is by making it part of user stories. Now, like with logging, you can also monitor and implement ways to monitor your business KPIs or functionalities at the business level, right? They are, as I mentioned before, Google Analytics is a really good example of how you track, you use, tools and libraries to track business KPIs and how you can then visualize them in a dashboard. Other ways are, for example, the implementation of this pattern, what is called semantic monitoring. So semantic monitoring talks about testing your system as using real-life examples and simulating what a real user will do. So you create these user journeys that are basically the same user journeys that you have defined that allow you to drive the development. And then you test them against production systems and your production services. So these ones will not only talk to one microservice, it will talk to multiple microservices because they will be across the whole system. You use what is called synthetic transactions. So that means that these transactions are not actually real ones. You are simulating a user. For example, if you have an e-commerce platform, that synthetic transaction won't fulfill the order or won't fulfill the payment, because otherwise someone is going to get a bill of things that maybe they don't want. So you kind of design and implement things in your system and in your services that allow for these transactions to exist without modifying the behavior of your application. Be also quite. It's really important that you also identify these synthetic transactions and what they are. So, you can't take, so for example, if you are measuring the number of users going through your site and the conversion rates and all that stuff, you need to obviously remove all these synthetic transactions from that, because otherwise you're going to have, unrealistic information, because, these are not real users. But they are a really good way to start getting metrics that are related to the business. And when you have all of these metrics, you obviously need to visualize them in a way that makes sense to you and makes sense to everyone. It is really important, and we found this really, really useful, that whatever tool that you use to visualize metrics is something that is accessible by everyone. So product owners, developers, architects, stakeholders, everyone should have access to this, and it should be something that they can use and they understand. So, a dashboard that gives you a single and unified view of how your system is behaving as a whole, and maybe you also want to have a specific graphs or visualization for your microservices. This dashboard should have a really important place in your team area. It should be in a monitor where everyone can see. It should be where conversation happens. When you talk to the product owner and you have a conversation about what are the effects of the last functionalities that we have implemented and how they have affected the business. Because you will have also business metrics in there, right? So you can have a completely different conversation than the one you have if that dashboard only has operational metrics, and then the PO has a completely different dashboard that you don't get to see when he or she tracks business KPIs. So having just one is really important. Now, there's also, the risk of going into, going too far with monitoring and going too far with this dashboard. We can end up with something like this when we have, way too many things that we are tracking and that we are visualizing. And, it might be really difficult to actually get any insightful information out of these dashboards because they have way too many information and things can get lost in the noise. I don't know how many things are failing here. I have no idea. Be very intentional about the things that you show and the things that you track. And also be quite aggressive about removing things that you don't use anymore. You can always go back to them. They're not going to be lost, but just don't put them in there if it doesn't make sense for them to be there. There are multiple tools that you can use to create these dashboards. Prometheus is a really famous one of them. It's open source. Datadog is a commercial one, and it's also quite easy to set up, and it's quite useful too. You can get really good dashboards, and it's really easy to configure. Now, we've been talking about all of this as a kind of pull mechanism. So I go to dashboard and look for information. I query or I track certain data points that will give me those insights. But there is always the opposite thing, right? So sometimes I want things to come to me because I'm not going to spend my life just looking at a monitor and trying to understand what's going on, right? So there will be also instances where I want notification to be pushed towards me, right? And a really good example of this is alerting, right? So I want to be alert of when things are going not in the way that I was expected to go, right? So alerts is also something that, probably most of us are familiar with. It might be that not all of us support products in production, so that means that maybe we never done on call or we never seen how alerts are actually being used, but we know the notion, right, of what an alert is. What we have seen in multiple clients is alerts are not usually being treated that nice, and we don't pay attention of how we format those alerts. So then the person who is on call end up receiving an alert and not enough information for that person to act and to do something. So we have seen that what it works is to be very intentional about how you format those alerts. Because yes, alerts will be actionable. They should be an action. I receive an alert, so then I'm expected to do something. But I need to be well informed that what something is. So, be very intentional about what has happened so that person knows, because the person might or might not be familiar with the service that is giving that exception. Make sure that, links to more information are added. So normally you will add a link to Kibana or Splunk. You will have a safe query that you can link that will give you, just a simple query that's filtered by that exception in the service that is giving throwing that exception in the last 20 minutes or in the last hour. So the person who is responding to that alert can really quickly go and start looking through logs or whatever it needs to do. And also give a course of action. What are the next things that the person should do? What are the things that they should try? So runbooks are really common. They don't need to be super exhaustive, but they can be just a really nice and direct and short set of steps. Of if you see this exception first, try to see if the servers are actually responding fine. What is the status of this? You can try to restart. You can try to deploy the previous build. Very specific 3-4 actions that person can take in order to resolve the alert. Now, you also want to be very pragmatic and create what is called smart alerts, because you can be alerted for a lot of things, and I don't want to be waking up at 3 a.m. because like this, a service is giving one single 500, right? It's okay, just send me an email and I look at it in the morning, right? But if that service is returning consistently, responding with a 500 consistently for all the requests for 10 minutes or 15 minutes, then there might be something going on, and there may be something that is very critical to the business and need to be solved at that precise moment. And in that case, sure, wake me up. But that's it. Also, there will be times when you don't need human interaction to resolve these alerts, and that's actually quite powerful. You can have, a job or an automated process that could deal with that alert. And a really simple example is how you can do auto-scaling. So instead of having to auto-scale manually when you receive an alert that a service is running over 80% of the capacity, CPU capacity or something for 10 minutes or 15 minutes, you can have a job that goes and spin up a new instance. Amazon and the way they do auto-scaling is based on this. So really simple. Well, not simple, really useful. It doesn't necessarily mean that it's simple. And then also there are, again, tools. I say that Amazon can actually allow you to trigger some actions in certain alerts. Prometheus also allow you to create alerts and that will have multiple parameters and multiple conditions and also assign actions, specific actions. And Observable is also a commercial tool that allows you to manage and create alerts, on-calls, and all that stuff.
So a lot of time when you're talking about monitoring and alerting, you're looking at data that has been rolled up to a higher level. So I usually want my alerts and monitors at a user level or at a business event level or at an endpoint level. Tracing actually goes the opposite way. Tracing is basically about finding one specific request by one specific client and being able to trace it all the way through your system, through your mesh of microservices. And microservices don't really make it very easy, right? Because I can have a bunch of microservices. If a request comes into the system, it might go to one microservice, but that might call 5 other microservices, each of which might call 2 other microservices, right? And even if I have all my logging in place, there are thousands of requests coming through my system. How do I figure out which of these logs maps to the actual request that I care about? So there's a common pattern to fix this in place, which is to use a correlation ID or a trace ID. So basically, whenever a request comes into your system, we generate a unique ID to identify it. And then as the request is passed down from microservice to microservice, this attached ID also flows with it. So that if I look at my logs, all the logs that have this specific ID in it tie to the specific request that I care about. So this is a good first step, right? And now I have a bunch of logs for each of my services. And in those logs somewhere there is a correlation ID that will help me figure out the path this request took. And as we discussed earlier, we already have log aggregation in place. So, I can go to one system, just do a search for this ID, and I get all the log messages that have this ID in them. So does that actually help me figure out the path of this request? And one thing to remember is that if you are tracing an individual request in your system, that's usually because you're trying to track down a problem. Either something is already breaking, or there might be a performance issue that you're seeing intermittently that you want to figure out. But there is a problem, right? So you want to get to its heart as soon as possible. So I have a correlation ID. I have a bunch of logs in my log aggregator. So if I go put in this ID and do a search in my aggregation system, I might get 100 different log messages, right? And now I have to manually piece together which of these logs happened first, which of these happened second, what data was passed from here to here. So even though I put in a bunch of logging, monitoring, alerting, and aggregation in place, this is still a very complicated thing for me to do. Now, ideally, what you'd want is some sort of a request graph, right? Which is a request has come in, this request went to this microservice first, then it went to the second microservice. The second microservice called the third and the fourth and the fifth microservice in order, and somewhere in there the request died. So I want to know which order things happened in, and I want these visualized easily for me, right? So there's a bunch of data that you need to track for this. Correlation ID is just one piece. And you need to make sure that this data is passed from service to service. And then you need to have a tool that allows you to visualize this. Well, the good news is that you don't have to build all of this yourself. Distributed tracing tools have seen a lot of activity in recent times. And there are a lot of open source and commercial offerings available. So you have Zipkin, Uber recently released Jaeger. You have Lightstep, which is a commercial offering. And all of these essentially provide you libraries that you can include in your services, and which will automatically track the data required for your tracing ability and make it available to this service. Another thing that's happening in this space is that there's a lot of standardization being built around it. So there's the open tracing protocol, which is a vendor-neutral protocol for adding and storing tracing information. And most of the commercial or non-commercial systems that we talked about earlier, Zipkin, Jaeger, etc., they all support it. Which means, the system actually comes with libraries for around 9 different platforms and languages. So if you're building microservices right now, there's really no reason for you not to think about tracing and include it in your systems.
Cool. So we have gone till the end of the talk. Before we open the floor for any questions, we just want to summarize the key takeaways that we have for you. Let's go a bit closer. So we felt and we feel that structuring your data in a way that can be consumed by third parties is, as we have shown, is really, really useful. You know, having a standardized way of producing and storing data that then can be used by your monitoring tool, visualization, or any other party, it will solve and it will go a long way. Be intentional about things that you log, monitor, and alert on, because you know, there is so many things that you can react to. That is very important that you are focusing on the right things, and you know, probably you won't get it right the first time, and that's perfectly fine. I don't think no one in here has done things the first time right. So it's all about the learning and about adapting and you know, be able to evolve with your system. Evaluate and use existing tools and library. Don't try to create your own log aggregation tool, because you know, there's people whose day job is just to do that. So you can probably just use one of them that works for you. Find that tool that is the best one for you at this moment in time. Use it, and then you can focus in the right important stuff for you, which is building the functionality that will bring value to your company and to your users. Proactively remove and iterate and remove noise and remove things that you don't use, because they are just there to create noise and to you know, not let you focus on the important stuff. And last but not least, standardize. Having a microservice-based system, it can be really good. It can allow you to do a lot of stuff. It could unlock the innovation, and it can do a lot of stuff, but at the same time, it came with a lot of complexity, and now we are in a distributed system, so making sure that all of the services have a standard way of doing these type of things can help you a lot on maintaining them and operate them in production. And that's it. Thank you very much. You have 5 minutes. So we have, I think, around 5 minutes. So if anyone has any question. Yes, so there is a question.
Hey, hi, hello, thanks a lot. Have you talked about tools for alert and monitoring? And have you tried the XPath from Elasticsearch? It's a pack from monitoring and alerting.
Oh no, I haven't tried myself, but it is true that a lot of these tools are now going into other areas. So you can have, Elasticsearch coming into how can you have an alert system on top of that. You also have, Prometheus. We talk about Prometheus, a way of tracking data and also alerting. So a lot of these tools are trying to do multiple things. Yeah, but I don't have any experience. Have you? Do you have any experience with it?
No, but I think it's a good option, and
yeah.
I need to find someone to have tried it, and I don't know. Thank you a lot.
Cool. Yeah. Cool. Any other question? Oh, cool.
Hello, and thanks for this talk. I'm using Prometheus to monitoring, to make the dashboard for monitoring, but the system people make me a question that there is no horizontal scalable tool.
Yeah.
And do you think that can be a problem, that you can scale this tool for?
I guess it could be a problem. I've never seen that Prometheus cannot be scalable, but maybe.
I know that there are other commercial. I know that there are other commercial cloud-based systems. For example, Weave, which are built around Prometheus, that give you a lot of the same features. So I'm kind of surprised to hear that it's considered a non-scalable system.
No, it's because they don't scale by nature. You have to scale it manually. There is not a tool that make Prometheus scalable at his own. You have to do it by your own.
Right. Okay.
So I can't speak to a specific case, but so Prometheus essentially is the time series based monitoring tool, right? And there are a number of other options, like Honeycomb, for example, that provide you the same capabilities, and they definitely tout scalability, easy scalability as one of the selling points. So you might want to explore. As microservices are becoming more common, all these tools in the observability space are undergoing a lot of innovation and change, and there are a lot of options right now. So it's very hard for me to say choose this one over the other, because they are all changing and evolving so much. But you should definitely try a few out. So even if Prometheus doesn't work for you, there are a lot of other options that should.
Thank you.
Cool. You can also come and talk to us either now or at the ThoughtWorks booth. We'll also be there. Thank you.